Skill 18, Triangle Congruence by Angle Side Angle and Angle Angle Side. Number 8, given segment QR is congruent to segment TS and segment QR is parallel to segment STS. We want to prove that triangle QRT is congruent to triangle TSQ. Okay, so what I'm going to do first on this one is I'm going to start with what I am given. So my given is segment QR is congruent to segment TS and segment QR is parallel to segment TS, and that's given. And as you can see, it is already marked on the picture. Now the next thing we have to do is we need to figure out how to get these two triangles congruent to each other. So I'm going to look at common things that I know about both. So I know that this line right here is involved in both triangles. So I'm going to use that. I can call the same line itself by the reflexive property. So that's my next step. So segment QT is congruent to segment QT by the reflexive property. Alright, now the next step is I'm going to look at some angles, because if I can get another angle involved, then I could go, angle side angle or side angle side or anything like that. So that's what I'm going to be looking at. So if I look at my angles here and my lines, I should see that these two lines right here are parallel. Right there and right there. So I'm going to extend them out a little bit, and if I extend out my transversal line, now it's just like the proofs that I've proved before. So I'm going to look at my angles. So what I'm going to try to see if there's a relationship between these angles right here, because they are sandwiched in between two congruent sides that we know of. Okay, so that's my next step. But if I look at these angles, my parallels, the transversal, they are alternating interior angles. So I know a theorem, the alternate interior angle theorem, that tells me that those two are congruent. So that is my next step. So I have angle STQ is congruent to angle RQT by the alternate interior angle theorem. And finally, because I have a side and then an angle and then a side and a side, an angle and a side, side angle side theorem tells me that those two triangles are congruent. So I would write triangle QRT is congruent to triangle TSQ by the side angle side postulate. Number 10, we are given that segment PQ is perpendicular to segment QS, segment RS is perpendicular to segment SQ, and that T is the midpoint of segment PR. And we want to prove that the triangles PQT and RST are congruent to each other. So what we're going to do for this proof is start with what we're given. So we write that down as our first step. Now we're going to look for like special geometry words that we use sometimes that might help us out. For example, we have midpoint right here. T is the midpoint of PR. So I'm looking at this line right here, and T is the midpoint. So what that tells me is that my PT here is going to be the same as TR because that's my definition of midpoint. So I write PT segment is congruent to segment RT by definition of midpoint. The next thing is I'm going to look at my angles. My angle here, Q, and my angle here, S, are both right angles. Well, that would imply that they're both equal or congruent to each other because they're both the same right angle. So that's what I'm going to do next. I say angle Q is congruent to angle S by the congruence of right angles theorem. And the next step is somehow we need to get another angle in there somewhere. So then we can use an angle side, or, you know, if we get another angle and another side, then we could do the same thing. But I think the easiest way to look at it is I see a pair of vertical angles right here. So I should be able to say that these two angles right here are congruent because of our vertical angles theorem. So that's what I'm going to go next. So that leaves me with angle PTQ is congruent to angle RTS by the vertical angles theorem. And finally, we have an angle, another angle, and then a side. Angle here, and side here. Angle, side. That means that the two triangles are going to be congruent. So that's my last step. I can say that triangle PQT is congruent to triangle RST by the angle side theorem. Number 13, angle FJG is congruent to angle HGJ, and segment FG is parallel to segment JH. We want to prove that triangle FGJ is congruent to triangle HJG. So we're going to start with what we're given. So we write down our given statement. Now we need to figure out where to go from there. There's several places we could go. We could look at common sides, or we could try to get more angles and go angle side. So either way, we could see what would work best. I'm going to start by looking at the common side, because it's a common side on both triangles, so it might help me out. So I'm going to say GJ is congruent to GJ. That's my step 2, and that is from the reflexive property. So now I have an angle and a side that match up, so I just need another angle or another side. Either way could work, depending on where it is. But since I cannot get the opposite sides to be congruent because I don't have enough information, I can look at the other angles. So I'm going to look at this angle right here and this angle right here, see if I can get those to be congruent, because then I would have angle side angle, which I know that can help me out in solving for a triangle. So when I look at the parallel lines and maybe extend them out a little bit so they look more like what I've done before, and there's my transversal line, then I should notice that this angle right here, GJH, and this angle right here, JGF, are the same because they're alternate interior angles, so I can use that to say they are congruent. So I say FGJ is congruent to angle HJG by the alternate interior angle theorem. Okay, and the last step, because I have an angle, then a side, then another angle on both triangles, I can use angle side angle postulate to tell me the two are congruent. It gives me triangle FGJ is congruent to triangle HJG by the angle side angle postulate. For 14, we have our given statement, which is segment AE is parallel to segment BD, segment AE is congruent to segment BD, and angle E is congruent to angle D. That is all given to us. We are trying to prove that triangle AEB is congruent to triangle BDC. Okay, so what I know is I have an angle and a side on both of them. So I'm going to use this idea of parallel to try to figure out another angle. Because if I can figure out another angle, then I can have angle side angle. So it would be nice if we could figure out how to get angle A here to be the same as this angle B here. because that would be helpful to us. So let's see what we can do with that. If I were to extend out this parallel line and this parallel line, and extend out my transversal line here, then what I have is this angle right here and this angle right here are corresponding angles. If they are corresponding angles, then I know that they have to be congruent to each other. So that's what I'm going to do. So I'm going to say angle A is congruent to angle DBC. Well, now I have, if I look at my triangles, I have this angle right here, side in the middle, and this angle right here congruent to angle, side, angle. So that means the triangles are congruent. So we say triangle AEB is congruent to triangle BDC by the angle side angle postulate. So that's it for your notes over Skill 18, Triangle Congruence by Angle Side Angle and Angle Angle Side. Summarize your notes, finish this worksheet, and then you should be ready for your quiz.